Assalamualaikum. My name is Madati binti Mahadi from University Technology Malaysia, Kuala Lumpur. Today I would like to present about my research. It is about electromyography and hand gripping force during sitting and standing. The musculoskeletal injuries contribute to the weakness and fatigue of the upper limb motion and muscle strength. This condition happens when a task was done repetitively. Any activity that was performed for a long time in the same body posture could also cause back and neck pain. Furthermore, musculoskeletal disorders among students have become one of the high-risk sufferers from musculoskeletal injuries. To the best of our knowledge, there are several reports of the musculoskeletal injuries and hand grip strength using EMG. The aim of this study is to investigate the effect of EMG time domain during sitting and standing while gripping and to identify the posture that are riskier for musculoskeletal injuries. The literature review contains the review of previous study concentrating on the use of smartphones repeatedly for a long period have reported that it can lead to musculoskeletal injuries. The high usage of smartphones other than computer usage is now led by the COVID-19 pandemic whereby most classes, conferences, and workshops are now being conducted online. This is some previous study. Abdul Hamid and Abdulazim at 2016 used hand grip strength to improve the ability of hand grip strength and symptoms that causes of musculoskeletal injuries by postural correction and exercise training program. Kim and their research group at 2016 used EMG to compare the among healthy students and with musculoskeletal injury using different hand posture when using smartphones. Another research named Kim and their research group at 2016 used EMG to investigate muscle activity response recorded by the EMG during sitting and standing when using a smartphone. ET26B and their research group at 2018 used EMG to investigate the using smartphones repetitively for a long period that can lead to musculoskeletal injuries. And lastly, a recent study, Ratwan and their research group used hand grip strength to investigate the impact of hand grip strength using smartphone repetitively with fixed body posture. This is my methodology. I use two equipment, which is a digital grip analyzer and a EMG from biomedics equipment. This subject will be given consent form and medical history form. Subjects are excluded if they report any type of disease, upper limb, dysfunction or perform any surgery at upper limb for 3 months. Prior to data collection, the skin needs to be properly prepared so that it can provide good signals and to avoid variance of noise. Before applying electrodes on the skin's surface must be cleaned using alcohol wipe and dry. The test will be repeated 3 times and the repetition provide the highest test. We test reliability with each test lasts for 5 seconds. Subjects will be given rest between tests for about 2 seconds to avoid any possible fatigue effects. This is my experimental setup. The EMG wireless transmit will be attached at the subject hand and the subject will grip the hand grip strength. Then the data will produce at the both monitors separately. These are the 2 different body postures that I use in my experiment. First, the standard posture protocol of American Society Hand Grip Therapy, which is the sitting posture. The subject will be in seated position with his shoulder conducted and neutrally rotate. Elbow flexed at 90 degree and the forearm and wrist in neutral position. The elbow and next the standing position, the elbow fully extended with the wrist in a natural position, no degrees. The flexor digitorum superficialis muscle and extensor carpi radialis muscle of the forearm are used. A set of features was extracted to characterize the EMG data for classification of the intended movement. The classification using various features can be achieved by analyzing using MATLAB R2070B for statistical analysis. In order to obtain good signal and prevent from noise, the filtering is need to be done using high-pass filters. As you can see at the slide, this is the three features values of experimental repetition at 3 time domains at sitting and standing posture. The repetition when doing the gripping tasks are particularly important for performance accuracy to provide the highest rest reliability. The value of features extraction increase as the number of repetition increase. It's observed that both subjects performed poorly during the first measurement of the hand grip strength and apparently did not use their maximum strength for the gripping task. After the subject are comfortable with the handle, the gripping performance increased for next 2 trials. This is the effect of different body posture on the 3 feature extraction at the both muscle. This is for my second subject. A t-test was performed and found that there is a statistically significant difference between every repetition time with 3 features extraction for different body postures. The results show the features extraction values with respect to body posture, while gripping activities are performed to compare which features were better, although the result produced with small number only. There is a statistically significant difference between standing and sitting posture for the 3 features extraction. There is also statistically significant difference between standing and sitting posture for the 3 features extraction. As you can see at the slide, this is 3 features extraction roll signal for both muscle. As you can see at the roll signals, the amplitude reach the maximum at early stage for both muscles because the subject start to grip the maximum hand grip strength at early stage of experiment. And the amplitude become decreased during gripping for a long time. Flexor-digitorum superficially muscle has slightly higher peak value signal than extensor carpi radialis. This is because the flexor produce higher value than extensor that can prove by previous study that during gripping tasks had significant value between the muscle. Subject for both muscles start to contract at 2.5 seconds because they start to grip using the hand grip strength with maximum at 2.5 seconds. As the conclusion, the value of features contraction have responded differently with the different body posture, although the value is small. This study shows that EMG for upper limb studies can produce slightly different value while standing and sitting, and not only studies regarding relationship hand grip strength and postures. There are also several limitations in this study which include a small sample size as there were only 2 male subjects that participated in this experiment. Only standing and sitting posture were tested, and the task only involved the gripping force according to the standard protocol with a different angle of the upper limb. Thank you.